Hello and welcome back. We have understood what is data distribution and what is random variable. Let us try to understand what is probability distribution. When we looked into this slide on data distribution, we have understood what is data distribution here. We have actually distributed chocolates, biscuits and ice creams. We tried to understand how many students have got and how many food items have been distributed. So we are trying to understand data by grouping on students and food items. So this is data distribution. With data, if you want to understand distribution, it is called as data distribution. By calculating probabilities using data and trying to understand distribution, that is called as probability distributions. For different kinds of random variables, different kinds of distributions are there. Let us try to understand binomial distribution. When the experiment's outcome has got only two outcomes. If you throw a coin, only two outcomes, either head or tail. Those kinds of data's probabilities or probabilities distributions can be calculated or understood using binomial distribution. If the experiment is Bernoulli trial, the trial is a Bernoulli trial. When I say Bernoulli trial, the experiment's outcomes are only two, either true or false, yes or no, head or tail, like that. Then the probability distribution can be assessed by using binomial distribution. So when we can understand data distributions, why do you need probability distributions? With probability distributions, you can actually predict future. So that's the reason why we are actually looking into probability distributions. In any distribution, the probability density function actually tries to measure the density of the probability. So in a simple words, if I have to say, the height of the bar is what it calculates. The probability density function calculates the height of the bar. So this formula actually can calculate the height of the bar or the probability of a Bernoulli trial. So the probability of getting 0 heads can be calculated using this formula, where small n is equal to 0 and capital N is equal to 5, because we have done 5 trials or 5 tosses of the coin. This is actually NCN, P to the power of n and Q to the power of n minus n. Here the small n is 0 and capital N is 5 and P is 1 by 2 and Q is 1 by 2, because the trial is Bernoulli trial with the probability for true is P and false is 1 minus P. When we throw a coin, when we toss a coin, getting head, the probability of getting head is 1 by 2. Not getting head is 1 minus 1 by 2, that is 1 by 2. So if you substitute those values here in this formula, you can calculate the probability of getting 0 heads. So using all the probabilities, we can actually understand the distribution. Let us first calculate the probabilities. When you flip a coin 5 times, there are total number of 32 possibilities. The first toss has got 2 possibilities, head and tail. Second toss has got 2 possibilities, head and tail. Like that, 5 tosses and all multiplied, all 2's multiplied is 32. Total number of possibilities are 32. What is probability? The events in favor divided by the total number of the possibilities. So if you want to calculate probability of getting 0 heads, that can be done by doing experiment. You take a coin, throw first time, second time, third time, fourth time and fifth time. You flipped it 5 times, and only the case you get 0 heads is getting tail on all the trials. So out of 32 possibilities, only one trial with all the tails is the 0 heads possibility. So the probability is going to be 1 by 32. Favorable events by total number of events. It's the ratio. Right? That's the probability. You can use the PDF function, probability density function. I said the density, the height of the bar is what is going to be calculated using the probability density function. If you substitute small n is equal to 0, capital N is equal to 5, and P is equal to 1 by 2 and Q is equal to 1 by 2, you get these. So it is also 1 by 32. So the PDF, the probability density function, is also calculating the same. If we want to calculate the probability of getting one head, again you can do experimentation. The only way you can get one head is on the first trial you may get one head, second trial you may get one head, third trial you may get one head, fourth trial you may get one head out of 5 trials. So 5 possibilities are there. On first toss you get head, second toss you get head, third toss you get head, fourth toss or fifth toss you get head. So there are 5 possibilities are there out of 32. So it is 5 by 32 is the probability of getting one head. The same thing can be calculated by substituting values into probability density function also. So we have got 5 by 32 here. So like this, you calculate all the probabilities and then try to understand the distribution. So to understand distribution, you can actually use numerical distribution or graphical. It is always better to do a graph because when your data is huge, you cannot understand data like this. If you have done 100 trials, 100 tosses, then you cannot actually look at the numbers and understand the data. So we can actually look at the probability distributions by looking at the graph. We have seen how to do this graph in the previous session. So x is equal to 0, that's nothing but getting 0 heads. X is equal to 1, getting 1 head. X is equal to 2, 2 heads. 3 heads, 4 heads and 5 heads. On x-axis we have taken the random variable. On y-axis we have taken the probabilities. And the graph is forming a bell curve here. So if you join all these tips, it actually forms a bell curve. So here there is one point I wanted to make. Whether you look at the data distribution or probability distribution, they're kind of similar, because if you don't calculate probabilities, how many number of times, how many possibilities are there to get 0 heads? Only 1. How many possibilities are there to get 1 head? 5. Because first trial head, second trial head, third trial head, like that 5. Right? How many possibilities are there to get 2 heads? 10. So even if you take out the denominator, the scale will not change and the graph shape will not change.